Okay, class, today we're going to be doing the linear application problems. Now, these are just exactly like what we're doing. Now they're only a little bit more wordy, where you got to substitute, instead of the formulas, you're going to substitute the equations to find the values they're asking for. Now, everybody look at number one. I want you to circle number one, because number one is very important. It's so important that I really don't think a video will do it justice. So we're going to work this one together in class tomorrow. So now let's move on to number two. Louise got scores. She made an 88, a 78 on her first two tests. What score must she make on her third test to keep an average of 80% or greater? So we're going to mark some key things here. She got an 88, a 78 on two tests, and it wants to know about the third test, and she wants an average of 30 or greater. So let's talk about how we would write that. So I know that she made an 88 and that she made a 78. And I know that she wants to keep an average of 80 or greater than 80. So greater than or equal to 80. Now, because it's average, I know these two numbers are going to have to be divided by something. Because the total test she's going to take is 3, I'm going to have to divide it by 3. But I still have to take into account that third test. So I would add both of those together. So when I did that, in order to solve this equation, I realized I must simplify the left side. So when I simplify it, I end up getting x plus 166. I'm trying to write here. All of that divided by 3, correct? And that's going to be greater than or equal to 80. So in order to solve, I know that I have to do what? Multiply both sides by 3 to get rid of that 3. The 3 cancels out, and I'm left with x plus 166 is greater than or equal to 240. So now I must take my 166 over to the other side of the equation. So I'm going to end up subtracting 166 from both sides. That is a 66, even though it doesn't quite look like it. And I'm going to end up with x having to be equal to or greater than what? Correct, 74. So that means Louise must get at least a 74 or greater on her next test. So take a moment to copy that down. Now let's look at number 3. If you didn't get everything, just remember to pause the video, and that'll give you a chance to get that. So let's look at number 3. A couple wishes to rent a car for one day while on vacation. Ford car rental wants $15 per day. So I'm going to go ahead and write that information down. $15 per day, in addition to 14 cents per mile. So that's 0.4. It's a little decimal here. While Chevrolet for a day wants 14 per day and 16 cents per mile. After how many miles would the price to rent the Chevy exceed the price to rent the Ford? So when would the Chevy, remember this side's Chevy and this side's Ford. So I want to know when Chevy would exceed. Exceed means to pass, to be greater than. So I want to know when it would exceed. And actually, Ms. B put a equal to sign, but I don't want to know when it's equal to or greater. I just want to know when it's greater. So in order to solve this equation, you're going to do it the same way you solve an inequality. I know I need my variables on the left side of the equation and my whole numbers on the right side. So if I bring my variable over, I'm going to bring over a 0.16, and that's going to be negative. So what am I going to get? 0.02x. It's going to be a negative. And then I'm going to take my 15 over. That's going to become negative, and that's going to be a negative 1. Okay, so when I divide by my negative 0.02, I'm going to get that X to be less than 50. Less than 50. So now let's go to the next page. Okay. Steve is saving to buy a car. He has decided he will start looking as soon as he has saved $2,000. If he has $1,100 in savings now and he can save $150 a month, how many months will it be before Steven can begin looking at cars? Okay, let's talk about it. He doesn't want to begin looking at cars till he's at $2,000. He's at $1,100 right now, and he's going to save an additional $150 per month. So does everybody see? That's how you would set up that equation. So at this point, I simply have to solve it. So now, in order to solve it, I need to isolate the variable. So I'm going to subtract 1,100 from both sides, and that gives me 150x equals to what? Correct, 900. So if I divide both sides by 150, I get that Stevie is able to begin looking for a car in 6 months. 6 months. Now let's take a moment. What I want you to do now is I want you to look at number 5 and see if you can set up 5 and work it. Okay, let's take a minute. I'm going to help set it up. I'm going to help set it up with you, but I'm not going to work it. I want to see if you can come to class tomorrow with the right answer. LED Corporation produces a CD read-write drive at the cost of $120 each with fixed costs of $36,000. The CDRW drive sells for $180. How many drives must the corporation sell in order to break even? So I know that the cost is $120 each, so I know that's times X, with an additional fixed cost of $36,000. And I want to know when they'll break even. Break even should imply when is it going to be equal. Well, if it sells for $180, I want to know how many of those I have to sell for to break even. So I'm going to let you work that problem out and let me know what you come up with, and we'll go over it tomorrow. Okay, hope you have a good evening. Enjoy. Miss Bill, see you tomorrow. Bye-bye.